What's up, guys? In this video, we're gonna prove the following question. Considering the power series from n equals to 1 to positive infinity of minus 5 parentheses to the power n over square root over n times x plus 2 parentheses to the power n. Find the radius of convergence r and the interval of convergence. Okay, let's call an equals to minus 5 parentheses to the power n over square root of n times x plus 2 to the power n. Then I know for sure n plus 1 is going to be equal to minus 5 parentheses to the power n plus 1 over square root of n plus 1 times x plus 2 parentheses to the power n plus 1. Let's use the radial test and compute the following limit. The limit when n goes to positive infinity of the absolute value of an plus 1 over an. Replacing the values that we wrote above and simplifying as much as we can, we're gonna have that this limit, it's going to be equals to the limit when n goes to positive infinity of 5 times absolute value of x plus 2 times square root of n over n plus 1. But this is the same as 5 times absolute value of x plus 2 times the limit when n goes to positive infinity of the square root of 1 over 1 plus 1 over n. But this limit is just 1. And then we have 5 times absolute value of x plus 2. By the radial test, it converges when the limit of the absolute value of an plus 1 over an when n goes to positive infinity is less than 1, right? Okay, since I know the limit, it's equal to 5 times absolute value of x plus 2, then 5 times the absolute value of x plus 2 should be less than 1 to make my series convergent. And it means the absolute value of x plus 2 is going to be less than 1 over 5. This means my radius of convergence is r equals to 1 over 5. Yes, because this expression here, this inequality here, means we have an interval with center in minus 2 and radius 1 over 5. Solving this inequality, we're gonna have the absolute value of x plus 2 less than 1 over 5 is the same as my x plus 2 is gonna be between minus 1 over 5 and 1 over 5. So if you add minus 2 in every single part of your inequality, we are keeping the inequality works. And then we're going to have x is going to be between minus 11 over 5 and minus 9 over 5. We know this series converges in the interval minus 11 over 5 till minus 9 over 5. That's for sure. But we must test for convergence at the ending points of this interval. If x is minus 11 over 5, this series becomes, so instead have x, we're going to replace that value, and then we're going to simplify as much as we can, and then we're going to get the series from 1 to positive infinity of 1 over square root of n. Wait, that's a p series with p less than 1, implies divergent. So I'm not going to including the point minus 11 over 5 in my interval. Now, if x is equal to minus 9 over 5, this series is, so I'm going to pick my original series and replace the value x for minus 9 over 5 and simplify as much as we can. As you can see here, we have this series from 1 to positive infinity of minus 1 to the power n over square root of n. by the alternating series, yes, I can use the alternating series here test because it is decreasing and the limit goes to 0. Then this series is convergent. Therefore, the interval of convergence is from minus 11 over 5 till minus 9 over 5, but here we're going to including the minus 9 over 5, so we're going to represent this with a bracket. And my r, as we said before, my radius of convergence is 1 over 5. Any questions? I hope you guys enjoyed the video. Give us a like, make comments, suggestions, subscribe to the channel, and see you soon.